Today on Town Hall.
Science is a team sport, and mentorship is really how we pass the baton to the next generation.
My name is Bill Russell. I'm a former CIO for a 16-hospital system and creator of This Week Health, where we are dedicated to transforming healthcare one connection at a time. Our Town Hall show is designed to bring insights from practitioners and leaders on the front lines of healthcare. All right, let's jump right into today's episode.
Welcome to Town Hall, a production of This Week Health. I'm Dr. Zafar Chaudry. I'm the Chief Digital AI and Information Officer at Seattle Children's. And I'm very honored to be joined by Dr. Vittorio Gallo, who is our Senior Vice President, Chief Scientific Officer for our Seattle Children's Research Institute, and he's also the Principal Investigator for the Norcliffe Foundation Center for Integrative Brain Research. Vittorio, welcome to the show.
Good morning, Zafar. Well, thank you very much.
Yeah, thanks for joining. So we're going to have a fun 20 minutes or so, asking a few questions, having a little back and forth discussion.
Yeah.
And we wanted to bring more visibility to the innovating pediatric research that we're doing at Seattle Children's, that your teams are leading. And it's quite interesting because you are also actively doing your own research and have been doing so for many years. So as the Chief Scientific Officer, what are your top research priorities for the coming year? And how do you envision advancing the mission of your institute?
Well, thank you so much for the question. So first of all, I'm really excited about my role at Seattle Children's as Chief Scientific Officer. This is really an amazing research institute. And I'm also excited about, and I feel really fortunate that I can continue to do my own research as a developmental neuroscientist. As Chief Scientific Officer at Seattle Children's, at a high level, my top priorities are centered on accelerating discovery in areas where we can make the greatest impact for children. So the child health is the focus. And this includes strengthening our focus on different areas of research, starting from pediatric cancer, genetic diseases, neurodevelopmental disorders. And we want to continue to develop areas of strengths, in particular data science, precision medicine, and community health. All these areas will be promoted by team science. I'm also committed to expanding our research in health equity and implementation science. And my vision is really to position Seattle Children's as a global leader in pediatric research by building on our existing strengths, promoting high risk, high reward science, and creating partnerships that enhance our translational capacity. We are all part of a pediatric academic center, so it's really important that we continue to focus on our mission, which is to generate scientific discoveries that directly improve the lives of children and their families.
Yeah, absolutely. Such an important work. I mean, the future of how we take care of kids directly lies with research. Yeah. And as your institute is doing a lot of innovative therapies that are currently being developed, what do you think are the particular new innovations that people should be on the lookout for?
Yes, I think we are really fortunate to have several cutting-edge programs at Seattle Children's that continue to develop innovative therapies. I think we will continue to be at the cutting edge, at the leading edge of developing new therapies in pediatrics. First of all, in the area of cell and gene therapy, we are leading cell immunotherapy for pediatric cancer and for autoimmune disorders. We have recently opened a new clinical trials for cell immunotherapy in pediatric lupus. And this is the first clinical trial for pediatric lupus. In the area of vaccine development, we are leading in the development of malaria vaccines, particularly in vaccine strategies that target liver infection. In the area of neonatal brain injury and neurodevelopmental disorders, our scientists continue to advance cell-based therapies to promote white matter regeneration and neonatal brain regeneration, as well as novel neuromodulation approaches to enhance brain plasticity in early development. And we're also exploring gene editing and RNA-based therapies to target monogenic neurodevelopmental conditions. So these are all very advanced therapies. We are really at the leading edge, and we are integrating findings in research labs and research teams directly in clinical and translational applications. Another area that is really important for us is sudden unexpected infant death, SUID. And this is really where the convergence of neuroscience, genomics, and regenerative medicine offers unprecedented opportunities to change the trajectory of early life brain injuries and developmental disorders. So there are a lot of opportunities, and we continue to be at the leading edge.
So that's all very exciting work that thousands of people are doing, not only at Seattle Children's, but other pediatric facilities across the nation, if not the world. Now, a lot of the audience for This Week Health are technologists like myself, many of which spend their time supporting research institutes in the adult and pediatric space. What would your advice be to those leaders in technology on how they can better support research into the future?
Well, I see technologies and everything that you do as fundamentally important. So it is supporting, but I think that the way that research has been changing now in the past 5 to 10 years, technologies and everything that you do are integral part of research. I don't see that as a exclusively supporting role, but more and more integrated. I would say that there is a direct synergy between technology and research advancement now more than ever. So emerging technologies, we have really moved from wet lab science to data-driven science. We used to be dealing with very limited sets of data, and now we have large data sets that as scientists we're working with. So emerging technologies such as single-cell genomics, artificial intelligence, organoids, and all in vitro applications will require a direct integration and synergy between what you all do and what researchers do. And I think this will continue. These AI models and these new platforms will continue to revolutionize how we understand and treat pediatric diseases. I also think that it's going to be important to continue to integrate environmental and other determinants of health into pediatric research, because this will be really important to continue to develop holistic therapies. I mean, developing children continuously change their interactions with their environment. They're exposed to different stimuli, and they adapt to stimuli, but also they continuously change in their exposure. So this is going to be really important to take into considerations in everything that we design in terms of therapies in the future. So I think that over the next decade, we will include all these aspects in pediatric research, but we'll also see more personalized, preventive, and participatory approaches to child health. So this will be the next generation pediatrics, and technology will play a leading role, a crucial role in everything that we do in these spaces.
Yeah, and I think you brought up some very interesting points, right? So everything seems to now be data-driven, and then you hit the nail on the head with the whole, this wouldn't be a conversation if we didn't mention AI a few times. And so when you take all of the data that is being generated, and of course my team sees that because we store the data that comes from research, it's massive amounts of data that could lead to the next breakthrough, the next innovation, but without us arming ourselves with the right tools that allow those researchers and PIs to do what they do best, then we will run into problems. And I think what we're seeing now is it's hard to store everything on premises, on campus. We're now looking at more cloud-based solutions to store all of these masses of data. And then we have to store them for a really long time, because in pediatrics, we have to store data for 15 years past the last episode. And that's really shifting the cost model from a technology and how that technology supports research, but also I certainly seen with interacting with the researchers at our institute, their technical skills have shifted too. They're coming to us with more technology skills than I've ever seen before. They're more talking about using data. They're talking about open source. They're talking about language, writing algorithms. And I know you have your own research as well. And I know you're using your own data. So could you share how you've used some of your data to develop breakthroughs in your own personal research space?
Yeah, so I will give you a few examples, but first of all, let me respond to your comments, which I couldn't agree more. I think one of the challenges that every will have to face in the area of data science and AI and machine learning is, first of all, the capacity, continuing to increase capacity for these huge data sets and huge amount of data that we will continue to store and analyze. And particularly in pediatrics, as you mentioned, that's a significant challenge, because when we talk about pediatrics and we talk about pediatric studies, obviously these are longitudinal studies, these are multi-year studies, and we have to follow developmental trajectory in children. So that increases our needs for capacity. There is also an issue about vertical integration. We've been really good at collecting data in many different areas. If I, as a neuroscientist, going back to your question, if I think about how neuroscience has evolved, we now have a lot of data on the molecular characteristics of different cells in the brain. We have a lot of data about their physiological characteristics, how they respond to electrical stimuli, and how they communicate with each other. We have data about how circuits work in the brain and how these circuits function impacts behavior. So we have a lot of data on behavior, and we have data on imaging. We continue to make a lot of advances in imaging in the brain. But what we are not good at, what we don't know yet, how do we vertically integrate all this information to make sense from the molecular to the behavior to the imaging, all this information that we have about neural cells and circuits in the brain. And we are facing this. I'm facing this in my own research, because in my own research, I work from molecular data to physiological data to behavior, anatomy, and characterization of neural cell circuits. And we're trying to figure out how we can integrate this information, because now, even in my own lab, if I look at how the research has changed, just a few years ago, we were dealing with limited data set, and now we have huge data in metabolomics, genomics. We are doing spatial transcriptomics to look at spatial distributions of gene expression in the brain during development. And we're doing a lot more electrophysiological characterization of the cells, but we still have to develop new tools to integrate all this information.
Yeah, it makes complete sense. So if you were providing advice to my audience who traditionally are all IT folks,
right,
what could they do to better support their researchers in their own organizations? What advice would you give them?
Well, I think that a couple of things that come to mind. So first of all, I think focusing on translation and translational research, and how can technology bridge the gap that exists between the bench and the bedside. I think for me, that is particularly important as a pediatric researcher. And it's really a core part of my scientific philosophy. So we want to make sure that we ensure successful translation. We optimize translation, because we want to invest in infrastructure that supports early stage discovery through to first in human studies. So I think if I am talking to the audience, the IT audience, technology audience, there is so much that you can do to support that direct translation from bench to bedside, and make sure that we can go from discovery directly to first in human studies. And this includes, from a research side, developing translational course, strong collaborations between scientists and clinical enterprise, being committed to regulatory readiness, but also from a technology perspective, developing new platforms and new digital solutions that can help this translation. So what I'm thinking about is how technology can synergize with all of us to build this kind of seamless continuum where discovery and clinical care can inform and enhance each other. I think we are in a unique environment to do that, and particularly as Seattle Children's, we can really accomplish this goal as we are one of the top pediatric academic centers in the country, and we are excellent both in clinical care and research, and in technology, of course.
Any specific projects you're looking at in the future that you're excited about?
My mind is always running with a lot of ideas and a lot of projects. And I think that's a good thing because we have such an incredible research community here and so many exciting projects going on at Seattle Children's. And also we have amazing clinical research and clinicians. I think that applications of AI and how we expand data science from a broad perspective is something that I have been focusing on for a while, and you and I have been developing new initiatives together. And I think this is going to be a project that will support both research and clinical care at Seattle Children's. So I'm thinking about projects from a research perspective, projects that will bring value. How can research bring value at a system level? How can research make an impact at a system level?
Yeah, it's very important that health systems view the marrying of the technology, research, and clinical, and also with the explosion that we're seeing in, well, A, how much data you store, and B, what you do with that data, and C, using artificial intelligence. Health systems do need to figure out how to marry those pieces together, take that leap of faith, make investments in those areas. And these are going to be longer term invest to save type of programs, right? You won't see potentially benefits on day one, but day 180, you'll start seeing things happen, intelligence coming from looking at that data that can help inform how your health system shifts, changes, improves, focuses, and even gets more patients involved in research studies, because we tend to miss all the right patients because of the discrepancy sometimes between clinical and research. And then when you wrap that technology layer across it and invest in the right way, I truly believe that there's a lot of opportunity for every health system to be more innovative. It's an exploding model of capability that I haven't seen in the 39 years I've been doing this. It's just astronomically growing. And if you do use these tools, your personal self, the AI is becoming so smart on a weekly basis that it's mind-boggling in terms of what that capability could be. And if we were able to apply that in the right way to research, even to what I would call support services in the healthcare system, we're going to see massive value being driven, but not on day one. That value may come 6, 9, 12, 18, 24 months down the line. So some of it is taking that leap of faith and understanding that this is the direction the world is shifting to. I don't see a world now where we will go back to how we used to do things. I think people will continue to push ahead. And this is across every industry, not just healthcare. And what worries me the most is healthcare tends to always be behind in terms of adopting or taking that leap of faith. So my hope is that health systems will want to do that. And the same thing we're working on together at our health system, right, is pushing everyone to see that forward-thinking vision to then be able to do more innovation using that marriage between technology, data science, as you said, research, clinical medicine.
I couldn't agree more. I mean, everything that you say resonates completely with me. I completely agree. I think that we should not look at research. Pediatrics is changing, has been changing, and now the next generation of pediatrics will be where research and clinical care will be fully integrated. And what I mean with that is that in the space of AI, we will look at how research can continue to improve, developing new strategies and new initiatives to promote early diagnosis and screening, for example, personalized treatment plans, and looking at predictive analytics for critical care. And even in the area, one of the areas that are closer to my interest, the behavior and developmental health, there has been significant applications of AI in identifying and characterizing neurodevelopmental disorders. For example, autism spectrum disorder, which is a spectrum disorder. It's very heterogeneous. And now through video analysis of behavior and facial expressions in children, we have a much clearer understanding of different types of autism, and we can support new therapies with interactive AI. For example, chat box, visual therapists. So we have an opportunity to reach out to families in a very different way from the way that we used to. And I agree with you that we are not going back. This is now the trajectory and how we're moving forward. Remote care and telehealth is another example that will continue to develop. And it's actually really important because we will be able to reach communities that, for example, Seattle Children's continues to serve, but they are very remote from our centralized facilities, right? So we want to continue to reach out to our families, no matter where they are, so that we can take care of all children in the region that we serve. So I think that there is a lot that we can continue to do, and this is an evolving landscape, and research will continue to contribute. And the leading pediatric academic centers of the future will be those centers where research continues to bring value to the system, to the entire system, not only in research, but also in clinical care.
Well, thank you. So as we wrap up, Dr. Gallo, what advice would you give young scientists who are just entering this field?
It's very challenging right now. We are all aware of the challenges that research and pediatrics in general and pediatric research are experiencing. So we need to keep in mind, first of all, how we as institutions can operate in a way that we support those individuals who want to take a career and want to enter pediatrics or pediatric research. So we want to be aware that the new generations will want to use these tools, will want to use AI, will want to be trained in these particular areas. It's going to be really important to think about mentorship and how we continue to mentor the next generations. And this has been one of the most rewarding aspects of my career. I've mentored many clinicians and many researchers, and I see this as a very vital part of my role here at Seattle Children's. So I plan to continue to support young investigators to make sure that they have access to outstanding mentorship, protected time, startup resources, and a supportive environment that values both curiosity and resilience and commitment to pediatrics and pediatric research. My advice to early career scientists is to stay passionate, to continue to be focused, stay focused on what they're passionate about, be open to new ideas, and continue to adapt to the continuously changing landscape of pediatrics and pediatric research, and also surround yourself with people who not only challenge you, but also support you in equal measure. So peer mentorship is really important. Continue to build networks, continue to stay engaged with other young researchers and clinicians. Science is a team sport, and mentorship is really how we pass the baton to the next generation.
Totally agree. And my advice to our IT colleagues who are listening into this podcast is It's really important for all of us as healthcare IT technologists to spend time with our research and principal investigators in our health systems, learn what they do so we can better support them through the technology stacks that we provide, understand their needs, and collaborate more than we typically like to do. So I would highly recommend that if you're working in an organization that has a research function, try and spend time with as many people as you can as leaders in the health IT space, learn what they do, attend some of the very interesting lectures. I've certainly learned that if you attend lectures, those lectures are at lunch and lunch is free. So you never know what you can get out of that while you learn the next innovation that's coming out of your health system. And working in partnership is going to be the way that we as health IT technologists can support our research and principal investigator colleagues. So thank you, Dr. Gallo, for sharing your insights and vision for the future of pediatric research at Seattle Children's. Your dedication to advancing innovative therapies and fostering collaborative efforts, it's truly inspiring. And we look forward to seeing the incredible impact that the work makes, that we can tell the national community about, and how we can all improve the lives of kiddos for the future.
Thanks for listening to this week's Town Hall. A big thanks to our hosts and content creators. We really couldn't do it without them. We hope that you're going to share this podcast with a peer or a friend. It's a great chance to discuss and even establish a mentoring relationship along the way. One way you can support the show is to subscribe and leave us a rating. That would be really appreciated. Thanks for listening. That's all for now.